Hi, in this video we are going to talk about how to define arrays in Matlab. So I already opened Matlab and saved a script. I wrote CLC and clear all. CLC is the command to clear the command window, and clear all will clear all the memory from the workspace. Now we will see how to define arrays in a Matlab environment. But before diving into Matlab, let's just see how to define row and column arrays, and then we will come back to Matlab. So what is an array? So an array, also known as a vector, can be defined as a row array or a column array. A row array has one row element or one row for elements in the row side, and also the column array is defined as one column, and it can have multiple elements inside it. So in the Matlab environment, we have to use these third brackets to define these arrays. So now let's jump back to Matlab and see how can we define these arrays or vectors into Matlab. Now let's jump back to Matlab and start defining the arrays. So first, I will input the comments so that we will know what to input. So our input array, let's just assume X as our input array. I'll define the row vectors first. So let's say X has a row vector as 0, 2, 4, 6, 8, 10. This is my series of data, or a row array. So I just assumed it. You can assume anything you want. This is just an example. Okay, so now let's just define it, how to define it in Matlab. So the first way we're going to see is to use space. So first we're going to use space to define a row vector, a row element array. So let's just say a vector name A. I'm just defining randomly to see how does it work. A, use the third bracket, and then we can say 0, and then space 2, space 4, space 6, 8, and 10. So I just use space between the elements, and that way Matlab knows that it is an individual element, and that way it will identify those elements. So now if I just run it, as you can see, this A variable has 6 elements, and 6 of them are in a row. So that's how we can define a row vector using just space. The second method I'm going to talk about is to using comma. So let's just define B, and let's input the third brackets. Now have input 0, then put a comma, 2, comma 4, comma 6, comma 8, comma 10. So this is another way. As you can see, I haven't put any semicolon at the end so that I can see the outputs in the command window. So if I just run it, as you can see, I have another vector or variable B that's outputting the exact same output as A, but now we have defined it in a different way. So these are different ways to output or have this exact same vectors. Now that we have defined multiple ways to use vectors or row arrays, let's just see what other ways we can define it. Now, if we have some series that is increasing in a constant way, so as we can see, this is a series where the first element and then is 0, and then it increases 2 at every step, and the last element is 10. So it's a series with uniform increment. Now, if this is the case, then you can use another trick. This is called using colon. So we will use colon to identify how to do that. The one thing to know is that if it's not a uniform series, if it's random numbers, then we do have to input that manually and define those vectors in Matlab. So let's just see how to use colon. So let's define C, another variable, and now the colon, using a colon, the format is like what? Format is start value, then put colon, and then increment, then the end value. So if we just take this example, the start value is 0, we'll put 0. Now we'll put a colon here. Now, as I said, the increment is 2 at each step, so input 2 here, and then put another colon. And then the end value is 10, so I'll just put 10. Now this C should exactly have the same row array as A and B. So let's just run it and see. As we've said, this is the exact same array that we wanted. Now, one thing to know is that if we don't use this increment, then Matlab has a default 1 here. So if I just, let's say, delete it and run it again, now you can see C has a variable, C is a variable with 10 values. So each increment is 1 instead of 2. So make sure that you use that input so that it creates your vector correctly. So and then if that's the thing. Now we can use another trick. We can use another function to do the exact same thing. So the function is called Linspace. So what is a Linspace? We can type help Linspace. So Linspace is a linearly spaced vector. As I said, this is a uniform series or linearly spaced vector. Linear increment here for this example is 2. So we can use this Linspace command to actually execute our data. The format you can see is the following: Linspace, then x1, the starting value, then, so let's just write here, what's the format is Linspace, and then that should be start value, comma, end value, comma, and then n is the number of elements. So n is the number of elements here. So this is very important to remember because this is not an increment like this. So if I just put 2, it will not output like from 0 to 10 with an increment of 2. It will just only output 0 and 10. So number of elements are like, we can count it. In our case, this is 1, 2, 3, 4, 5, 6. It has 6 elements. So if we want to use this, we need to have n as 6 here. So let's just define another variable d, and let's use Linspace, and then start value 0, comma, end value 10, comma, number of elements. Now, number of elements, as I said, should be 6. And if I close the parentheses and just run it, as you can see, D has the exact same vector as A, B, and C. Now, as I said, if you input 2 here, it will not do the same. It will just output 0 and 10 because it's a number of elements. One other thing to make sure is that you should input this number. If you don't, then Matlab has a default 100 in this place. So if we don't place anything, it will just output hundreds of data points for this vector. So always make sure how many number of data points you need and then run it. And that way we can actually identify and output multiple row vectors or row arrays in MATLAB environment. Now that we have learned multiple ways to define row arrays in MATLAB, we will define how to use column arrays in MATLAB. So just to recap, this is the row and column array, what it looks like. So the column array should be a column, and it should have only one column data. So let's see how to define this column array in MATLAB. So I opened the MATLAB again, and I will press this plus sign to open another script, and I'll save this as another, so let's say array underscore column, just to define another thing. I'll put the CLC and clear all here, and now let's just see how to define the column arrays. So we will do this. I'll just comment column arrays, and here let's say we can define a row array and use an apostrophe to transpose it to make a column matrix. So what do I mean by that? So as we learned before how to define a row vector, we can use the same thing, but we can use this command, which is the apostrophe sign. If we do that, then it will transpose the vector or the matrix, and then that way we can have a column vector or column array. So let's just see, as we defined it with the previous example, a vector 0, 2, 4, 6, 8, 10. Now if we just do that and run it, it is defined previously and it is just a row vector. Now if I just put this apostrophe at the end, now if I run it, you can see the output instantaneously changes to this column vector. So this is one way to define it. Okay, now we can also define it like what we did it, comma 0, 2, comma 4, comma 6, comma 8, comma 10, and do this exact same thing. The B should have exactly same column vector. Okay, so now we can use semicolon actually to between the elements to create a column vector or array. So what we mean by that, let's just define another vector C. Now instead of just putting a comma or a space, if we just put semicolon in between the elements, 0, semicolon 2, semicolon 4, 6, 8, and 10. So now this C will have exact same column arrays as A and B. So let's just run it, and that's it. So instead of using a comma, if we use a semicolon, that way Matlab knows that this is a column array, not a row. Okay, so now we can do similar things, like we can do so this is how we can define column arrays in Matlab. Now that we have known how to define a row and a column array or vector in Matlab, we will see how to know the length of this vector. So if this is a long vector or long array, there's chance that we can't just count it. So we need a function to know how many elements are in there. One way to do that, let's just define another variable d quickly, and I'll use a colon to define a row vector like that. So now the d should be a row vector. Now, as you can see, one way to know how many elements are there is to go to this workspace, and if we just double click on any of these variables, and that way you can see how many elements are in there. So you can see here it says 1 by 6 double meaning the variable format is double. We'll talk about data types later, but this is a data type, so it's just a number. Now 1 by 6 meaning it's a row vector and there's 6 elements in the row side. If we double click on any of the column vectors, you can see it's a 6 by 1 double, so means there's 6 elements in the row side and there's 1 column. So this is a quick way to identify rows or columns, and the number of rows and columns. If we want to know exact value, or include that in the programming, so find the length. I'll just comment on that. So if we want to know that, so first thing we can do is to use length function. So we can use a length function. What is a length function? We can just type help and length. It is actually it identifies a length of a vector. So if we if we just say, let's say, define a vector d length or d len, whatever, I'll just say 1. I am just defining randomly. Whatever you want, you can define it. Now equals, let's just use the length function and use a vector. In this case, I'll use d. And if I just run it, this dlen1 has 6 as value. So there's 6 elements. The length of this vector is 6. Now there's other way that we can define it. So we can use another function that's called numel. So it's numerical elements. So let's just define another variable dlen2 and use numel, say d, and that way we will see how many elements are there. And as you can see, dlen2 has 6 elements. So this defines how many elements are there in this array or vector or a matrix. So these are 2 functions that we can use to identify the length of any vector. So now we will see how to figure out a specific value of a defined element. So what do we mean by that? So let's say d variable has 6 elements. Now if I just say find a particular element value. So if I just say what's the first value that d has, so this is called indexing. So if I just type d and do the parentheses, and if I just press 1, it starts from 1. So if I just do that, and that way it knows that the first it will print the first element. So if I just run it, as you can see, the first element of this d is 0, so it outputted 0 here. Now we can say what's the third element. You can type d parenthesis 3, and that way you will know the third element, which is 4 here. One thing to notice is that Matlab starts the indexing from 1. It doesn't start from 0. So if you have 0 here in the index, it will not take it as an input. So it starts always from 1. So the first element is d1, the third element is d3. Now if we want to know the 6th element, we can do d6, and that should be 10. Yes, that is. The other trick to know the last element is to use the end command to actually figure out what's the end element value. If I just run it, it's going to show 10. So as we have this, we have defined this vector like really small. It's easier to see from clicking here, but if we use multiple matrices and also multiple, like, number of elements are huge, then these commands are going to be really useful and doing programming. So this is how we can do it. The other thing that I wanted to show is how to know the length or a number of elements from a matrix perspective. So this is how we learn the vector. So let's just define another matrix. Define a matrix. So matrix has both the row and column at the same time. So a vector does only have one row or one column, right? So let's just have a matrix as a variable, okay? And then I'll do the third bracket, and let's define the matrix as 1, 2, and semicolon 3 and 4. I just defined it so that it's a 2 by 2 matrix. So if I just run it, and you can see it's 1, 2, and 3, 4, the elements are here. So I just defined it as an example. We can have multiple rows and columns and define it as it is. So now let's define the length of the matrix. So what is the length? Let's say length matrix. And if I run it, let's say the length is 2, because if I just click on this matrix, you can see it's a 2 by 2 matrix. So there's two rows and two columns, so the length is 2. But if we want to know the elements, the number of elements, then we do have to use the numel command, because that actually calculates the number of elements as a sum. So if we do that, then it should count all the number of elements and it should have value of 4. So that's the difference. When we use a matrix instead of a vector, if we want to know the number of elements, we should use a numel command, and the length actually gives the n by n, or row by column, for the matrix. And that way we can define the length. The other thing I want to talk about is to access to different elements of matrix. So let's just say here we just defined 1, and it outputted the first variable. We defined 3 and put the third variable. Now here in the matrix, if we just do 1, there's multiple things. Like 1, it doesn't know, is it the first row, first column, or what? So to do that, we have to define the row first and column separated by a comma. So the first value should be the row address. Here, let's just say the first row. I want to have the first row, first column value, which is 1 here. So I'll place the first row value as 1, comma, first column value as 1. And if I run it, it should give me 1. Okay, now if I just say matrix 2, comma 1, so go to row number 2, column number 1, and run it, as you can see, this one appears, number 3. So it's row 2, column 1. And then similarly, we can use 1, comma 2 to access this one, which is 2 here. And also if we do matrix 2, comma 2, so row number 2 address, column number 2, which is number 4 here, so it should give you number 4. So this is the trick to access multiple locations of elements in a matrix environment. So if it's a vector, we can actually use 1, and that way it doesn't need to be defined as a row or column. But if it's a matrix, we need to define it as row and column so that it knows which value to look for. The last part I want to talk about is how to add some value to these elements. Okay, so let's say I want to add something. Let's say I have this vector d, and I want to add some value to some elements of this vector. So let's add 1 to the first and third value. Okay, so let's just see how to add first and third value to vector d. So let's just see how to do that. So one way to do it is to know the first index was d1, so this is the first value, and we know the first value was 0, so we'll say first d1 equals, equal is the assignment operator here, so we'll assign the d1 value something different. So we'll again say d1 because we want that element, the value, and then plus 1. So we want to add 1 to this element value and then assign that summation to the location of the first index of that array. So if we have 0 here, it will come as 0 plus 1, and then that will be 1, and then that 1 will be assigned to the first location of that vector. Similarly, we can see if we want to access third element, we'll do d3 equals d3 plus 1. So this way it will access third elements, which is number 4, and then plus 1 gives you 5, and that number 5 will be assigned to the third element of this array. So let's just run and see what happens. So if we see that Let's see for for this line, this is the answer. So as you can see, instead of 0, it printed 1, and the rest of them are the same. So 0, 2, 4, 6, 8, 10 becomes 1, 2, 4, 6, 8, 10. Now, as we wanted to add 1 to the third variable 2, you can see the third variable was 4, but now here it became 5. So this is the way that we can use access multiple data elements and also add or subtract or do any arithmetic operation on that. So to recap, in this video we have learned how to define the row and column arrays in Matlab environment, and also how to find different lengths of the vector and matrix. And at the end, we have seen how to access different addresses or elements, and also how to do an arithmetic operation to certain elements. That's it for now. Thank you for watching. See you in the next one.